So here's a question. Just take a minute to read it. The velocity of a particle moving along the x-axis is differentiable. Okay, so that's important. They've told us we're differentiable, so we also know we're continuous if we need it. Where the position of the particle is measured in meters and time is measured in seconds. So we're given velocity here. These are meters per second. And they ask us, is there a time on the interval 18 to 24 such that the acceleration is 1/2? So I'm thinking IVT because it's asking for a point. Like, what is the y value? The problem is the y values are not given because we were asked for acceleration. So that means it's not an IVT problem. Acceleration is the derivative of velocity. So all of a sudden they're asking for the derivative. This is an MVT problem. We must be looking for when the derivative is equal to the average rate of change, or the velocity at 24 minus the velocity at 18 all over the time 24 minus 18. And they tell us acceleration is 1/2, so we know the 1/2 part. We're saying, is that equal to, well, the velocity at 24 is -6 meters per second, minus the velocity at 18 is -9 meters per second, all divided by 24 minus 18 is 6 seconds. Notice our units are meters per second per second. That is an acceleration unit. So we're doing this right. Well, 6 minus a negative is really 6 plus 9, so that's 3 over 6. Sure enough, the average rate of change does equal the instantaneous rate of change. So the answer is yes. But we have to pick up all the key pieces. Since v of t is differentiable on this interval 0 to 50, it is therefore continuous on the closed interval 0 to 50, and the mean value theorem guarantees that there is at least one value of time on that interval 18 to 24 that a of t equals 1/2 because v of 18 minus v of 24 over 18 minus 24, and I switch these, but it doesn't matter, you can get the same answer either way, is equal to 1/2. Since you've shown that your average rate of change gives you the same value as your instantaneous rate of change, and we know we're continuous and differentiable, then we can say yes. So these are all the things that would have to show up. You'd get probably 1 point for showing A rock equals I rock. So that would be this right here would be +1. And then you'd get 1 point for saying we're differentiable, therefore continuous, and the mean value theorem applies. That's how this would be graded.